Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0793, indicates an issue with the intermediate shaft speed sensor A circuit. This code specifically signifies a no-signal condition from the sensor, which is crucial for the operation of the continuously variable transmission, CVT. The intermediate shaft speed sensor is located on the CVT drive pulley and monitors the rotational speed of the intermediate shaft. It communicates this data to the engine control module, PCM, which uses the information for optimal shifting and overall vehicle operation. Since this error stems from an electrical circuit issue, a mechanical transmission problem is not the root cause. Electrical issues can include problems with wiring, connectors, or the sensor itself, and the troubleshooting process is necessary to identify the exact cause of the malfunction. The intermediate shaft speed sensor plays a vital role in monitoring the vehicle's speed. It's part of the CVT system, which allows for seamless acceleration without gear shifts. Located at the CVT drive pulley, its primary function is to relay the rotational speed of the intermediate shaft back to the PCM. This information is essential for determining the appropriate timing for shifts, thereby optimizing performance and fuel efficiency. If the sensor fails, or if there are issues in its circuit, the PCM may not receive critical data, leading to potential transmission performance problems. Understanding the location and function of this component is crucial for effective troubleshooting. The P0793 DTC is primarily caused by electrical circuit problems, not mechanical failures. One potential cause is an open circuit, where the electrical connection between the intermediate shaft speed sensor and the PCM is disrupted. This could result from damaged wiring or poor connections. Another possibility is a shorted wire, where the wire makes unintended contact with a ground, causing the sensor to signal incorrectly. Lastly, the issue might originate from a defective sensor itself, which fails to send the necessary signals to the PCM. Each of these causes necessitates specific troubleshooting steps to accurately diagnose the underlying issue. When DTC P0793 is triggered, drivers may experience several noticeable symptoms. One of the most common indicators is the illumination of the check engine light, which signals to the driver that there is a malfunction. Additionally, the vehicle may exhibit performance issues, such as stuttering or hesitation during acceleration, particularly if the transmission is unable to shift correctly due to a lack of sensor data. Drivers might also notice a decrease in fuel efficiency or unusual engine behavior. Being vigilant for these symptoms can help in early identification of the issue, allowing for timely troubleshooting. The first troubleshooting step for diagnosing DTC P0793 involves validating the issue through specific procedures. Begin by turning the ignition switch to the on position, either by using the key or pressing the engine start-stop button. Next, utilize the Honda Diagnostic System, HDS, to clear any existing DTCs. After clearing the codes, it's important to start the engine and disable the Vehicle Stability Assist (VSA) system by pressing the VSA off button. The vehicle should then be driven with the shift lever in D and maintained at speeds above 19 miles per hour for at least 30 seconds. Finally, slow down and stop the vehicle. This process helps confirm if the P0793 DTC reappears, indicating that the failure has been duplicated for further testing. In Step 2, the goal is to determine the possible failure area in the circuit. First, turn the ignition switch to the lock position, or press the engine start-stop button to turn the vehicle off. Then, disconnect the CVT drive pulley speed sensor 3P connector, ensuring safety while working on electrical components. After the connector is disconnected, Turn the ignition switch back to the on position to prepare for voltage measurements. Using a multimeter, measure the voltage between the specified test points. The CVT drive pulley speed sensor, terminal number 1, red, blue, and body ground. Verify if there is voltage reading around 5 volts. This step will determine if the system is functioning properly or if further diagnosis is required. Step 3 focuses on evaluating the VCC1 line for continuity and voltage stability. With the ignition switch set to the on position and the CVT drive pulley speed sensor 3P connector still disconnected, measure the voltage again, this time between test points designated for the VCC1 circuit. Specifically, check the voltage between test point 1 at the CVT drive pulley speed sensor terminal number 3, yellow-red, and body ground. The expected reading is approximately 5 volts. If this voltage is present, the circuit is functioning correctly, and one would move on to step 4. However, if the voltage is absent, it indicates an open in the VCC1 wire, requiring immediate repair or replacement. Step 4 entails a detailed examination of the CVT drive pulley speed sensor itself. Ensure that the ignition switch is still in the on position and that the CVT drive pulley speed sensor 3P connector is disconnected. Proceed to measure the voltage between the test points for VCC1 and SG1. Specifically, from test point 1, sensor terminal number 2, GRN-WHT, to test point 2, sensor terminal number 3, yellow-red. Again, the anticipated voltage reading should be around 5 volts. If this voltage is verified, it indicates that the sensor is operational and can be replaced if necessary. However, if the voltage indicates a fault, repair may be needed in the SG1 wire leading back to the PCM. The 5th troubleshooting step is aimed at checking for shorted wires on the NDR line. First, turn the ignition to the lock position to ensure safety before proceeding. Then, activate the short circuit selector, SCS line with the HDS to monitor for any shorts. Next, disconnect the PCM connector B, 51P, along with the CVT drive pulley speed sensor 3P connector. This enables continuity checks between test points 1 and 2, focusing on the NDR line. The test points established are the CVT drive pulley speed sensor number 1, red-blue, and body ground. If continuity is present, it indicates a short to ground in the NDR wire. If continuity is absent, the NDR wire isn't shorted, leading to the final troubleshooting step. The final step in troubleshooting the DTC P0793 involves checking for continuity in the NDR line. The ignition should be in the lock position, and both the CVT drive pulley speed sensor 3P and PCM connector B, 51P, should be disconnected. Measure continuity between the CVT drive pulley speed sensor terminal number 1, red-blue, and terminal number 44 on the PCM connector B, also red-blue. If continuity exists, the NDR wire is confirmed good. The next action would be to check for updates on the PCM software, replacing it if required. If the continuity test fails, it would indicate an open circuit in the NDR wire between the sensor and the PCM, necessitating repairs before the problem can be resolved. After completing all necessary repairs and troubleshooting steps, it is crucial to perform a final verification. Reconnect the relevant connections and use the Honda Diagnostic System, HDS, to check if DTC P0793 is still present. Ensure that all necessary data has been cleared first. A successful repair would be indicated by the absence of the DTC upon rechecking. Following this, Test driving the vehicle is vital to confirm that all systems are functioning normally, particularly the transmission. Look for any signs of performance issues that were previously noted. This comprehensive verification ensures that all root causes have been addressed. Preventive maintenance for the intermediate shaft speed sensor and its circuit is essential to avoid future occurrences of diagnostic trouble codes like P0793. Regularly inspecting electrical connections and wiring can help identify early signs of wear or damage. Ensuring that sensor terminals are clear of dirt and corrosion is equally important, as this can affect signal transmission. Additionally, keeping the PCM software up to date can mitigate potential issues stemming from outdated programming. By establishing a routine maintenance schedule that focuses on these aspects, you can prolong the life of the transmission system and enhance overall vehicle performance. In conclusion, diagnosing and repairing DTC P0793 requires a systematic approach focused on electrical components rather than mechanical repairs. The intermediate shaft speed sensor is critical for proper transmission operation, and any failings within its circuit can lead to performance inefficiencies or safety concerns. By understanding the purpose of the sensor, identifying possible causes, and following detailed troubleshooting steps, mechanics can effectively resolve the issue. Furthermore, routine preventive maintenance can significantly enhance system reliability and reduce the likelihood of similar DTCs arising in the future. Awareness and proper care will ultimately ensure a smoother driving experience for Honda Civic owners. Please like and subscribe to the channel. See you next time!